Okay, sorry that this is going to come out slightly later than intended. I just recorded a whole answer and I'd not turned the microphone on in my screen recording. So I'm going to go through this again really quickly using everything I did. But I don't know, there's your answer to jump to if you forgot anything. But let's go through this. Yeah, okay. So whilst I solve this thing using a hyperbolic substitution. A hyperbolic substitution means we either use sinh or cosh in further maths. Generally you're not going to have anything different to that unless you're told explicitly. So what does it make sense to let x equal sinh of something or cosh of something? And well, we have in general this identity, right, that cosh squared minus sinh squared, sorry, let's put some things in there, is equal to 1. So that's going to imply that the square root of cosh squared minus 1 is equal to sinh x. Right. I can plug one to both sides, square roots. This is the form that I want for this thing. So, and you can see this doesn't hold if I switch these two things around. It only works one way. So that's my kind of inclination that the right substitution to use for this is going to be x is equal to cosh u. Okay, so let's work out some things about this which you can use later in the question. So if x equals cosh u, we have dx is equal to sinh u du. We also have then this and tells us that u is going to be equal to arc cosh of x. And we obviously, the whole reason we chose a substitution is because we have sinh of u is equal to the square root of x squared minus 1. Okay, so let's work through this question. So I have I is equal to this thing here. Let me plug in my substitutions. So I'm clearly going to get cosh squared u. This thing at the bottom is sinh u. And then I've got my sinh u for my dx. So those cancel because we're not doing analysis. We don't need to worry about holes or zeros or anything in this. So I'm left with the integral of cosh squared u du. Okay, so how do we proceed from here? Well, recall if we're doing this as a trigonometric thing, we don't know how to integrate cos squared x dx by itself, right? We whenever you've done this integrals, I'm sure you've done many times, and as we did loads during polar integration, what we have to do is use the double angle formula for cosines. If we want to integrate that thing that I just wrote down and paused off there, we use the fact that cos 2x is equal to cos squared x minus 1. Now, the key thing with hyperbolic functions, and indeed why they're even called, like, why is it called cosh x? Like, what makes it similar to cosine and sine? Well, obviously we have the differentiation rules, but actually it's these formulas as well are really useful. So we have the fact that cosh 2x is equal to cosh squared x minus 1. 2 cosh squared x minus 1 even. I can't remember what I wrote down last time. Of course, I don't know if you're given that in the formula sheet. You might be given it. Hopefully you are. But you can't just assert things in maths, so we're going to prove it for the sake of it anyway. So the left-hand side is what, 1/2 e to the 2x plus e to the minus 2x. The right-hand side, so that's the left-hand side. The right-hand side of this thing is going to be what, 2 times, and then, well, I'm going to have, let me kind of do this math quite quickly. I'm going to, we don't need to be doing group theory today. Did I just cross that off? Oh, no, there we are. Okay, I'm going to bring out 2 factors of my half that I'm going to get and compound that with the 2. So I'm left with e to the x plus e to the minus x squared minus 1, which is equal to 1/2. And then I'm going to get e to the 2x plus 2, and then plus e to the minus 2x minus 1, which is, hey presto, going to give me 1/2 e to the 2x plus e to the minus 2x, which equals the left-hand side. So if you were given that as a separate proof, that's how you do it. But in any case, all of the double angle and compound angle formulas that you know from ordinary trigonometry holds with hyperbolic functions too. Specifically then, I can split this up. So I have this is equal to 1/2 plus 1/2 cosh 2u du, which is equal to a half u plus, and then we know how to differentiate this, right? It's going to give me 1/4, integrate this, sorry, sinh 2u. Okay, so now we're really close, except from we have this thing sinh 2u, which we don't quite know how to do. We have u, we've written down there, we have sinh of u, but we don't quite have it. But again, we've just proven this thing holds for cosh of 2x. So why don't we prove it holds, well, we have sine of 2x, right, is equal to 2 sine x cos x. So it makes sense. Let's propose sinh of 2x is equal to 2 sinh x cosh x. Okay, how do we prove that? Well, again, we do the same thing. I'm not going to bother writing the left-hand side down because I'm sure you'll know what it is. So the right-hand side is going to be 2, and then I'm going to get 2 factors of a half out, and then I'm going to get e to the x minus e to the minus x, e to the x plus e to the minus x, which is clearly equal to 1/2 e to the 2x minus e to the minus 2x, because that thing and that thing, the cross terms are going to cancel because they have opposite signs, which is clearly equal to sinh of 2x, which is the left-hand side. So there you go. As a proof for that one, and so we can split this thing up here. This is equal to 1/2 u plus 1/4, well, 2 times 1/4 sinh u cosh u. And I'm sure the eagle-eyed among you spotted that I should have had a constant the whole time there. Okay, let me take out a factor of a half from this and then plug in my thing. So this is equal to 1/2. U, we said, was equal to arc cosh of x. And then this thing here is going to be equal to x for my cosh u, and square root of x squared minus 1 for my sinh u, and then leave my c how it is. And that's exactly the answer they wanted, because addition commutes for real numbers. If you'd like, if you wanted to switch those around, you could. But yeah, that's how you do it. Key steps are really spotting this, why you should make this substitution. You could probably still make it work if you'd done the sinh as well, but it'd get more confusing. It's often nice to do that. You can see there's not actually that much algebra, especially if you were given the double angle formulas for sinh and cosh. But you can work those out, you can prove them, look in 2 lines, and then you can work through the thing very quickly. So hopefully that